So, yeah, hello everyone. This is Christian Block speaking from Germany, in detail from Cologne. So good afternoon, everyone. Thank you for the introduction, and thank you for inviting me to present ECLASS. So what I want to do today in the next 55 minutes, to give you a short introduction to ECLASS and why it is a dictionary of contextual semantics and structures for digital twin. What I mean with semantics, contextual semantics, and digital twin, I will come up in a few seconds. So maybe a short word to me, a brief introduction. So my background, I studied mechanical engineering at the Universität of Bochum, near to Cologne. So I'm not sure if you are familiar with the German geography, but nevertheless, I stayed in Bochum. I was a research associate for 4 years. So the last 5 years I did my dissertation, and last year I started with a new job at the German Economic Institute in Cologne. And the German Economic Institute founded a company, the IW Consult, which is supporting the ECLASS EV. So it's a German acronym for association. And we are setting up the head office of the ECLASS EV. So what's my research and knowledge background? So I did a lot in modeling, where we need ECLASS again. I did a lot of connectivity things like OPC-UA, MQTT. I did the data visualization, and then I came to simulation of production systems, and that what brings me to digital twins. I put all this knowledge together with a lot of engineering and a lot of IT stuff, and wrote my dissertation where I developed a methodology of for semi-autonomous modeling and event discrete simulation in cyber-physical production systems. So in short, I developed a decision support system for planning purposes with the digital twin. And what missing in this when I studied and when I was working on different projects, I found out that there's a lack in machine interpretable dictionaries, and that was the step to ECLASS. But a short step further, what do I mean with digital twin and what we mean in Germany with digital twin? So a short definition before I come to all the problem stuff, etc., just to make this term clear. So maybe we have a product or production system or what we can imagine. So we have 3 steps defined on the German standardization roadmap. So first we have a digital model. I think that is known to all of you. So a digital model is modeled manually. So we have a production system or product which is modeled manually, and this is a one way. So then we have the next step. I think this is quite, it's also quite new. So we have this digital model, which is connected to the product. So it is automatically updated. So that is what we call digital shadow. I think the digital shadow term is not so widespread globally, but we all talk about the digital twin, and digital shadow and digital twin are used as synonyms. What is this digital twin? So we have autonomic, connected, and automatically updated digital representation of a product or maybe a physical asset. And on basis of this digital representation, the digital twin can support a human engineer, for instance, or it can make decision support by itself and bring the data back to the product. So it's a two-way data connection. So we have a full digital representation which can decide for itself. But this is a future outlook, and I come to that later. So what I want to do today, so I want to start with a short problem statement. What is the problem in data exchange? Then come to the point of ECLASS. So the main point of this presentation, what is ECLASS and how can it support this data exchange, and then bring this together, how ECLASS can support the smart factory or Industry 4.0 or digital twins. So all these terms belong together. And I structured this, so coming from the history of ECLASS to the what it's new and where we are, what we are developing right now in the problem statement, and the same for the third point. So how these problems can be solved and solve the problems of the future. So let me start with the short problem statement. So I think you come from product sector, or I think this is a good understandable problem. So we have different companies exchanging product data. So we are looking on the product data lifecycle, or let me call it a data supply chain. So in between different companies, we have to exchange product data, product descriptions, and this is in a way that each participant in this communication chain understand it as send it, so that each party in this communication chain understand the sender of the message. And that is not only facing one company, and the exchange between a company, it's also facing the communication internally. So for instance, we have the company B purchasing products from company A, and then we have a link between the companies, and there maybe product catalogs have to be exchanged. That's one point where products and data has to be defined in a standardized way. But furthermore, we have between the purchasing department and the distribution of the real product, we have logistics, production, maybe we have the engineering, and furthermore, we have after sales. So all departments inside of a company have to talk the same language. And that on a human level, I think that is the easier part, but we have to exchange data automatically and machine interpretable. And then maybe in the future, we send back data from the field. So we have the full data lifecycle. We have the product in field. We have the product, the testing area of our customers, and the data sends data back. The product sends data back, and we have to understand this in maybe after sales and putting this data back to engineering. So how does it look in detail? For instance, on the production field, so we can call it a Babylonian confusion of languages. For instance, we have two robots which are controlled with a PC system, a software. These robots are connecting to a product, and maybe we have a customer with his smartphone try to locate the current status of the product. Well, the big issue here, all assets are talking different languages, and so the connection between all things, so the robot A and the robot B, is not as easy as expected, and then the product needs another format, and yeah, so on. So for instance, the software has X1, whereas the robot B has just an X and Y, and the product maybe defines coordinates with the length. So it's not interoperable, and it's not so easy to connect these systems. But where we want to go in the future, so let me make this more global. So we're talking about the smartification of a connected world. So we have smart health, smart mobility, smart home, smart grid, and where we want to focus right now, it's the smart factory, and today the smart factory. So the problem is growing. So many more assets want to connect to a network, and maybe the factory, the smart factory, wants to communicate with the products which were produced in the history, and they want to communicate with the smart grid, and maybe these products are connected in a smart home, and so on. So we have a really connected world, and what is really necessary is that all is connected with these two terms. So we have to and how does it support all this stuff we want to achieve? We have to focus surely quality, time, and costs. That's what we're facing in production, but we have to focus also on interoperability. So that is the main reason for ECLASS, and this brings me to ECLASS. So we need an interoperability between all assets we connect in the future. So coming to ECLASS. So if you have questions, please feel free to ask and interrupt me, okay? What is ECLASS, and how can it support these problems? So ECLASS is the hierarchical standard for master data to classify and describe products and services. So as we can see on the right-hand side here on this slide, we have these 4 red colored segments, groups, and classes, which we call a classification tree. And then on the 4th level, we have the possibility to link so-called application classes to the 4th level of the classification tree. These application classes allow to describe products. I will come to this in detail on the next slides. So we have, on the one hand, we can classify products. So say this is the robot on the one hand. Furthermore, we can describe the robot. How many axes does this robot have? How many connections, inputs, outputs, etc. does this robot have? And so on. Furthermore, we have a lot of taxonomy inside of this dictionary. Altogether, we call ECLASS a dictionary. We can put keywords to classes to find these classes for humans, and we can put so-called synonyms to properties to find also different spellings for properties with the same meaning. So altogether brings us to a semantic interoperability because we define properties in a standardized way. So when we define a property, machine can use this property and understand what this meant. So where can ECLASS be used? On the one hand side, we can use ECLASS for sales and procurement. So that is the history of ECLASS. It was founded around about 20 years ago with the focus on sales and procurement, where standardized catalogs were necessary. So catalogs had to be exchanged, and the properties of the products needed to be understood from sender and receiver in the same way. So this was the starting of ECLASS, defining electronic catalogs with the common and standardized semantic. Furthermore, a step further, then the requirements were defined with ECLASS. So define the length and the width on the color maybe with the machine interpretable semantics, and exchange these requirements with the sales departments of the other company, and these requirements were understandable for humans and machines. Furthermore, supports then strategy and controlling. So you can put E-class as one classification and product description in your systems, and this helps you to control your sales and procurement departments. And altogether, it supports processes. So there are no more media breaks in data transformations in all these data exchange processes. So this was fully automated, and this knowledge and this good and this success in sales and procurement was was taken and put to the next phase, the engineering phase. So E-class is also used in engineering. So we can use common, understandable and machine interpretable product descriptions also in the engineering phase. And later, that is the next step, using this data in the production and later in the digital twin. And we are not doing this because of we are happy with the machine interpretable standard, and we are putting a lot of effort in this. If you use E-class, so you get these slides after my presentation, you can save a lot of money with standardized data exchange. So I don't want to go into detail in this slide. You can read it by yourself later on. You can save a lot of money using standards in data exchange. So a few facts and figures about E-class. As I said, on the right bottom here, E-class is around about 20 years old. So they started in the year of 2000 with the focus on sales and procurement. On this starting year, they had just 10 members, and now 20 years later, they have 150 members. 150 members does not mean users of E-class. So we have more than 4,000 users, and users, I do not mean people, we mean companies using E-class in data exchange processes. For this data exchange, at the moment, we have more than 45,000 classes to classify products. And to describe this product, there are more than 90,000 properties available in the dictionaries. So where you can save with these classification descriptions is that you do not have any translations and mappings between different formats, since this is included in the dictionary right now. We are doing this not only in Germany or in Europe. E-class is spread worldwide. So translations for definitions, preferred names, etc. in at the moment 16 languages. But we are open for new ones. We cooperate with global companies and global associations for standardization and E-class integration in different systems. So as I said before, we have a global network right now with different offices and supporting members like TUV SUD Korea right now. Yeah. So I come back to this in a few seconds. So a few more facts. E-class itself is based on ISO and IEC standards. So E-class uses these standards to model the dictionary and exchange the dictionary. If somebody is interested in these standards, we can talk about this in the next days just on request. The main benefit of E-class, that is machine readable. So we have a dictionary based on the ISO IEC standards, and this is exchanged in different types. So the most common type is the XML representation right now. We are working on a JSON representation, but this is also future. So the dictionary can be used to transform this dictionary in other exchange formats and include this in other data systems. So I talked about sales and procurement. So eClass can be used in BMECAT, for instance, electronic catalogs, or in Automation ML, as shown here, and then later in the digital twin, the asset administration shell. So the main advantage is that this is machine readable, and then you can include it in other formats and interpret it via machines. So it is not only a German or European standard, it is multilingual, so it's international used, and not only in the production or product-oriented or automatization context. It is used in different domains. So we have electronic components, okay, we have, but also larger like trains described in eClass. We can also describe the service to offer a transportation, medical processes in chemical facilities. Yeah, of course, the automatization things. We have furniture in the dictionary. We have a lot of consumable stuff from the office perspective. We have food and beverage, etc. So, and as I said, eClass supports consistent use. So started in a sales and procurement phase where product data was exchanged with catalogs. We are now at the phase of using eClass in engineering, for instance, in Automation ML, where the data which was exchanged between companies is later used in the engineering phase. And now we are coming from this engineering phase and reusing this data in production and operations. So the machines producing products can reuse the engineering information on the one hand, and on the other hand, production assets are products itself, so they are described with eClass and can communicate between each other. So, but eClass itself is not working, so we need the integration in other standards, and therefore eClass and the eClass Association works together with ISO, IEC, Building Smart, the DIN, ETIM International, ApplyAPI, and furthermore. And eClass is not finished right now. eClass is developing further releases, so it is open for change requests. You can say there is missing something, you can model it, and then the new properties, classification classes come into the next release. And what is to say here, we have constant updates, yes, and additionally eClass offers so-called update files, so you can use machine interpretable update files to update your data. So if you have catalogs, Automation ML files using a prior eClass version, you can use this update files to update to a new release. A few words to the association before coming to some details of eClass. So the association has at the moment 27 steering committee members. Maybe you know a few of them, large global players. I don't want to call one of them, so you can read it by yourself. You can get these slides later. So we have a lot of ordinary members from large companies, but also small and medium-sized companies working in the association to develop the E-Class standard and bringing in new topics. Furthermore, we have smaller ones as supporting members. Yeah, but these are only members which are come together and developing further and new concepts. We have a lot of more E-Class users. A few corporations in Europe. Maybe you know the API standards, the Building Smart Initiative, yeah, ETIM maybe, and then the Hardis Group. The Hardis Group is the company from France. They are setting up the regional office in France. We have the I cannot spell this. That is Czech. That is the regional office for Russia right now. Paradigm. This the regional office for Eastern Europe. And more globally, we have cooperations with CINES, that is the Chinese Standardization Institute. We are cooperating with the Industrial Internet Consortium. It's more US focused. We are working together with JATA, the Japanese electronic and product oriented association. We are working together with Profibus initiative, the RKWC. It's the consulting house which is setting up the regional office in China. Stibo Systems, the regional office or the company hosting the regional office for the US market, and not to forget TUV SUD, or here in special South Korea, yeah, hosting the office for the South Korean market. So coming back to the E-Class structure. So as I presented a few minutes ago, E-Class is a 4-level hierarchy for classifying systems. So we have, on the one hand, we have classification classes, which can be used to group products and yeah, classify them. For this purpose, E-Class defines an 8-digit code, which can be used as a class code to classify systems. So we have, for instance, a segment 27 for electronic components, and then we have further groups down to classify detailed electronic components. And on the 4th level, we have so-called the application classes, which can be used to characterize these product classes in detail. So linked to these application classes, we have these property structural elements. Properties can be used to characterize these classes. Characterization is only possible if you define specific data types for these properties, and if these properties have maybe a number, a data type, it is necessary to define a unit. Furthermore, it is possible to link a value list to these properties, so you can define predefined sets of possible values. Maybe we have a value list of colors, so we can define red, green, yellow, maybe for a traffic light. So you can describe a traffic light and the possible states of the light of this product. Yeah, as I meant, we have keyword synonyms. These are just translations and alternative names for classes and properties. And then we have aspects, blocks, and reference properties. I will come to these 3 types on the next slide. But how does it work in general? So each of these structural elements has a unique identifier. In eClass, we talk about so-called IRDIs. So these are International Resource Description Identifiers. And these slides show the structure of such identifiers. I put one example here. So the 0173 points to the domain of eClass. Then we have a -1. This only said we have a dictionary, the main dictionary. Then we have the hash. And then we have a 02. That means here comes a property. If there would be a 01, that would be a class. And then the part AAO677 is the identifier of a property. And then we have a version code at the end. So this ID is the machine interpretable identifier for a structural element, the property for the manufacturer name. So we wouldn't write manufacturer name in exchange formats in the future. We would write this identifier for manufacturer name and put just the value, maybe Siemens at the value for this property. This makes eClass the machine interpretable and global semantics for data exchange in the future. It is used in sales and procurement processes, in engineering, but in future in digital twins. So just with the machine interpretable identifier and contextual information, I come back to this in a few minutes, a digital twin can be connected to other digital twins, and a digital twin can be, can fulfill all requirements in the future. So coming back to the description, so we have the 4 levels of classifications, and then we have the application classes. If we have application classes, eClass difference between 2 types of application classes. So modeled is only the advanced one. So in the advanced application class, we have a lot of features. I come back to this on the next slide, where you can describe the product in multi-dimensional ways. So you can set up so-called blocks where you collect and summarize different properties. And in the basic representation, you have just a flat list. So how does it work? You model a full product description with the full brightness and all possibilities eClass supports. And then you say, okay, this property in the structure shall be also included in the basic representation. So you have a so-called basic flag, and this property, for instance, would be automatically point to this basic application class. So what do I mean with advanced concepts? So eClass is not only a flat list, as you have seen in the basic representation of properties. So we do not have maybe a light bulb, maybe a classified light bulb, which is described the supply voltage and maybe power consumption as 2 properties in a flat list. Maybe we want to describe it in a much more detailed way. So we have maybe a manufacturer, or surely we have a manufacturer, and then we have a supplier. This manufacturer and supplier attributes and properties can be summarized in so-called blocks. And so we can reuse these blocks in our product description. So we can, if we have a flat list, we can summarize some properties, bring them together, and reuse them in blocks. So this block concept is used in the next a little bit more complex modeling features. ECLASS supports also a cardinality. What does this mean? If we think about a product like a car or a motor vehicle in a general way, such a car has doors. So if you have a classification of such a car, you wouldn't describe the full brightness of all alternatives such a car can have. You model it with the cardinality feature, maybe. So, for instance, such a motor vehicle can have several doors, but you are not sure how many doors. The number of doors is set on the real instance or maybe catalog item, a product description. So you would use the cardinality and say only that this classification and an application class has a property for number of doors, and this number of doors is linked to so-called block, and then dependent on the number of doors, the block describing a door is linked to the product description. So you have maybe 3 doors, and then you can describe all 3 doors in different ways. And then going a step further, maybe you have different type of doors. To support such modeling and describing feature, we have the polymorphism. Maybe you have 3 doors, but not each door is the same. Maybe you have driver doors and a hatchback. And then you can use this polymorphism and select the door type, and then independent of this type, we have a different block and different properties to describe these product features. So how does it look in the dictionary? So we have several areas in the dictionary. So we have, let me say, one cloud of properties, and these properties are reused in a cloud of blocks. So maybe we have a block 1, block 2, reusing the properties from the first cloud. Yeah? And then maybe you can reuse this block in so-called aspects and predefine structures. And then you can use these predefined structures inside of the application classes and define product descriptions. And this brings me to the initial topic of this presentation and the title. So I called this presentation contextual semantics. So why? As you can see here, we have the property 3. So normally you think that is the same property. Yes, it is, but in different contexts. So on the one hand, we have this property 3 on the root level of the aspect 1, and then we have again it in block 1, and we have it on the root level of the advanced class, application class. So what does it mean? Maybe the property 3 describes a color. Yeah, easy example. And in the aspect 1, you maybe describe just one part of the product, and then in block 1, maybe you describe the just one side of this part, maybe the inner part, the internal color, and so you describe a context inside of the production description. And so you can reuse the property 3, which is maybe a color, and with the structure description, you define contexts. And this makes ECLASS so powerful. So ECLASS does not define just properties, it also defines structures and contexts. And then to finalize this slide, the advanced application classes are linked to this classification tree, and this is the full brightness of the E-class dictionary as conceptual model. So all I presented here is managed with the system. E-class uses the content development platform, which is available online on eclass-cdp.com. So everyone can go to this website and browse the E-class content. And additionally, you can create so-called change requests. So you can say in this portal, you can say, okay, I need, for instance, a new classification class, and then you can add application classes and start describing this product application class. And what you can see here, each of such structural elements has an IRDI. We have preferred names. We have definitions. We have the unit system linked to this properties and so on. So it's a full dictionary which can be used in different kinds of data exchange. So coming a little bit more to data exchange and where E-class is used. So if we have several systems, system A and B, we exchange data on several layers. So we have transportation and application layer. Maybe you know this OSI model. So we have different layers to bridge. We can do it proprietary. Okay, that's fine, but then we are not interoperable with other systems. So in the last years, there were many standards for different layers developed, and we see it converge in the IP on the network layer. And then we have different transport layers and session layers. Of course, we need them because we have different requirements. But, and this is the main message I wanted to give to you, we need a standard on the presentation and application layer. So we need a common data or meta model and information models and serialization models to define common semantics to be interoperable between the systems. So here we just define the techniques and the technology basis for a data exchange. But the main reason for data exchange is the data content, and the data content and the description of the content has to be understandable for all systems. So here we need standards, and here we see E-class as new standard in this OSI model. So, and how do you use this in further application is not defined yet. So how does it work and how E-class is used? Starting again with the BME card. So if you have an electronic catalog, you would describe different product features. And as I said a few minutes ago, you wouldn't say you have a number of different parts here as a string, or maybe you would have the translation in German or a Korean synonym here. So we have different languages. This would not be understandable for IT systems. So E-class can be used to define a unique ID to be understandable for this number of parts you can describe in such a catalog. Coming from a catalog and the sales and procurement phase to engineering phase, E-class can be used in automation ML. So E-class defines a white paper how to use E-class in automation ML, or maybe the CAEX format. This is the basis of automation ML. For the first step, eClass defined the basic representation, so include the classification and product description on the one layer system. Oh, sorry for this issue here. And then we are working on a second version of this eClass integration in Automation ML. So a full integration of the classification and products properties in the role class library, which can be reused in the system unit class. So the system unit class library is comparable with known catalogs. So here we have product description with concrete values, and this can be reused in an instance hierarchy to describe interfaces and relations between products and the full system. So eClass supports also the data exchange in the engineering phase. It is used in, for instance, the control cabinet construction, where you have a housing, and then you have rails, and then you have clamps, and all these relations can be defined here, but it is necessary to describe maybe the brightness of the box, the houses. You need the length of the rail, then you need the position of the concrete clamp, and all the properties for the product are defined in the unit class, and then you can describe the relation here in the instance hierarchy. And this is only possible in a common way if you use eClass. So, and then coming to the last point, the digital twin part. So leaving the engineering phase, coming to the real world and coming to product instances. So maybe in the future, here's just one example, maybe the washing machine defines a request for a different a spare part in life cycle, or maybe the product type requires a special part for production. So it requests a consumer unit, and this again requests a further part, and then these data can be exchanged automatically via defining machine interpretable requirements. And these requirements are understandable for all participants in this communication system, and they can offer proposals and send back concrete product descriptions, and later then digital twins of this product. And then we can set up a digital twin first, maybe a digital twin as type, and then we can build this and come back to the concrete instance of the product, which had the digital twin as well. So, but what is missing? So I think you know this reference architecture model Industry 4.0. So we have different life cycle phases. We have the hierarchy in our production fields, and then we have different layers. So today I would just focus on two layers, on the communication layer and the information layer. So the one say how we communicate, and the second say what we communicate. So just two examples. If we talk about communication, we say, okay, we have, for instance, on the instance level, so the machine can communicate via OPC-UA. But the big question is, what does this machine communicate? Okay, on OPC-UA, we have these companion specifications. Okay, that's fine. But if you want to communicate it globally and maybe be interoperable with other systems, you need a dictionary with its international use. So we need a machine interpretable description of the data and information that is transmitted, and that is eClass. So we have to integrate eClass into digital twins in the future. So and as defined in Germany in the last years, we have the asset administration shell as the digital twin, as the digital representation of products in the future. And as defined in the specifications right now, so for instance, such an administration shell can contain so-called submodels, but submodels can contain properties. And these properties can describe product features, variables, references, etc. But what is necessary is a semantic reference, so that a product feature is not described as color or Farbe, or I do not know, Farbe in Germany, sorry. I don't know the translation of Korean. So we do not want to describe it in proprietary systems. We want to have a global, understandable, and machine interpretable identification of such descriptions. So the product feature needs an ID, and furthermore, the ID of the unit is necessary. And here a short example. The digital twin defined in the asset administration shell uses so-called semantic IDs, and these semantic IDs point to E-class IRDIs, and this allow a global a global exchange and a machine interpretable data exchange, which can be understood and allows an interoperability between systems. So a few E-class members developed the so-called Asset Administration Package Explorer. It's a first visualization of such asset administration shells. I made some screenshots of this application, so everyone can download this application from GitHub. If interested, I can send the URL to you as well. So if you start this application, you just see this screen, but you can import submodels from a dictionary. So E-class is one of these dictionaries. And if you have a license for E-class, and if you have the files of E-class, or if you have in future the web service, you can select a special segment. This is only done because of the size of different segments. Or you can define, okay, I want to import a special IRDI. Then you can use the web service, and then you can select necessary attributes and properties, and you can import such a submodel. And then you create the basis of a digital twin. So you define a interoperable and machine interpretable digital twin representation in the asset administration shell. So where you import all things which are already included in the E-class dictionary. So you import names, etc., but you want to be interoperable, so you import the E-class identifiers, including all context informations which are included in the E-class dictionary. So furthermore, the asset administration shell defines so-called concept descriptions. These concept descriptions are similar to the E-class structure element descriptions. So it's more or less a copy of the structure element, which can be reused inside of the asset administration shell. But it is standardized from E-class and developed from domain experts, and becomes understandable for machines. So, and here this concept description in use again. Yeah. So furthermore, this is just one possibility for the data exchange in the digital twin and the usage of E-class in a digital twin. So on file level, in the future, it has to be exchanged. And here, E-class cooperates with the OPC Foundation, and the OPC Foundation offers a specification, so-called dictionary reference right now. And this dictionary reference allows to integrate E-class in the OPC UA world. So it's not only integration in different file systems, it's also the integration in communication and different architectures. So coming to the end of my presentation, so ECLASS is on the one hand a classification system, yes, but furthermore it defines structural elements and structures to describe products, but not only physical products, also immaterial products, so-called services. And ECLASS can be used to describe data points. So data, ECLASS makes data to informations. So in general, ECLASS forms the semantic basis for different formats in data exchange, like BME-card or Automation ML, and the digital twin, like the asset administration shell in the future. Because it is a uniform and machine-readable description, which can be exchanged and passed from computer systems. So in general, it provides metadata for data, and so it supports the interoperability between business units, surely, but it supports the interoperability of systems as well. So ECLASS will be the basis for collaborations or stronger collaborations. In the future, it will be the basis for marketplaces. We are working on such marketplace with the Yoda Foundation, but this is too much for such a presentation today. It will be the basis for new business models, because business models become more and more digital, so we need data exchange. Yes, it is the basis for Industry 4.0. It will be the basis for machine reasoning, and then, of course, the basis for autonomous systems. And to fulfill this this outlook, we're working on REST interfaces to exchange ECLASS. We're working on a so-called fast track. So the fast track will allow you to define new structural elements in a really fast way. So if you have a company, you are working in a company and a property is missing, but you need it in your communication, you can define it immediately, use it in your communication, and then in the next release, this is integrated in the global standard. So we are working on dynamic descriptions, like descriptions of capabilities. We are working on new serialization formats. ECLASS is serialized as XML and CSV at the moment. We are working on JSON, and furthermore, we are working on the RDF representation. Yeah, and this allows then integration in furthermore exchange formats like the Web of Thing description and the asset administration shell. Yeah, so I'm at the end. Sorry for the 2 minutes too long and overtime, but yeah, that is the presentation of ECLASS and how ECLASS can support the digital twin in future. I hope I could give you a short overview of these systems. And yeah, if you have questions, I will share these slides, and you have then my email contact and phone as well, so you can contact me directly. Thank you.